Hello everyone, welcome to our next lesson. Today we're going to be looking at first principles. What first principles does is gives you a very good image of how derivatives work. So later on we're going to get all these rules and you're going to be told how to find the functions of power functions or exponential functions or logarithmic functions. But this first principle shows you how it works. So what we've got here is, if we've got some kind of function, so I'm going to just draw a function, let's just say, something like this. And you've got one point here that you want to find the derivative of. Let's call it x and y, or x and f of x. Now you can find another point, let's say right here, which would be, well, let's say that this point, between this point and this point is h. So then this would be x plus h. I've moved over h in the x direction, and therefore your y value would be f of x plus h. Okay, so now I've got 2 points. If I want to find the slope of the 2 points, I would do rise over run of the straight line, but that doesn't give you the slope right at this point. It seems like the slope is always changing. Here it's 0, but now it seems to be increasing. So what we're going to do is we're going to make this h get closer and closer to this point. Let's call it A. It's going to get closer and closer to the point A. So if I drew another line to this point here, well, that's even better. That slope is getting better to the point instantly at A. But we can get better. Let's get closer and closer to the point where you have it right on top of it. And that would give you the slope or the tangent of point A. So the formula is f prime of x is equal to the limit as h approaches 0. So the distance, so right here, our distance from here to here was h, and we made h get closer and closer and closer to the point A. So as h approaches 0, of f of x plus h minus f of x divided by h. So to give you an example, let's suppose I've got my function f of x equals x squared, and I want to find the slope of this function. Well, f of x is equal to x squared. The derivative, we put a little tick here, f prime of x, is equal to limit as x approaches 0, or h approaches 0 of f of x plus h minus f of x divided by h. So, what do? The limit as h approaches 0. And we're going to substitute, instead of just f of x, we're going to put x plus h in it. So it's x plus h squared minus f of x, which is x squared, all divided by h. Now if we put in h equals 0 into this, you would get 0 on the bottom, and that just doesn't work. So let's play around with it. The limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared divided by h. And we notice that the x squared and the x squared are gone. And we also notice that we can cancel out the h with the h and the h. And what we're left with is the limit as h approaches 0 of 2x plus h. And now we can do our last step is, as h approaches 0, this would be equal to 2x. And what that's saying is our function x squared, not a great drawing, let's say it goes through 0. So let's say at x equals 3. At x equals 3, our derivative, or our slope, is equal to 2 times 3 equals 6. So at x equals 3, our slope is equal to 6. At x equals 0, so 2 times 0, our slope is equal to 0. And that makes sense. We have no slope right here at the bottom. At x equals -1, our slope is -2, and we have a negative slope. Anyways, hope that helps. Have a good day, and I'll see you in class.